In Python, the string format method is used to format strings by defining placeholders within a string using curly braces. These placeholders are then replaced by the values specified in the arguments. This is the syntax of a placeholder in format method. Curly braces define a replacement field which is replaced by the value of an expression inside it. Each field can also specify an optional set of format specifiers which control how values are presented when inserted into strings. These specifiers define how the value should be formatted, such as alignment, padding, precision, type, integer, float, string, etc. Format specifiers start with a colon. This is the general structure of format specifiers. The meaning and syntax of the format specifiers depends on the type of object that is being formatted. Type specifies the format type, which is the type of formatting applied to the corresponding value before inserting it into the format string. For example, there are string, integer, and floating point format types. String format type S. The value is formatted as a string. In this example, hello is formatted as a string. But unlike the default format, format type S only works if the input is already a string. Used for the precise string formatting and ensures only strings are formatted. Integer format types. Only works with integers. If used with a float, string, or other non-integer type, you will get a type error. In these examples, 90 is formatted using different integer format types. Binary format type B formats an integer as a binary number base 2 without a prefix like 0b. Character format type C formats an integer as a Unicode character. 90 is the Unicode code point for Z. Decimal format type D formats an integer as a decimal base 10 number. Octal format type O formats an integer as an octal base 8 number without a prefix like 0O. Hexadecimal format type lowercase x formats an integer as a hexadecimal base 16 number using lowercase letters A to F without a prefix 0x. Use uppercase X to format using uppercase letters A to F. Floating point format types. Works with integers and floating point numbers. Fixed point decimal format type F formats a floating point number in fixed point decimal notation. This means it will always show a fixed number of digits after the decimal point, even if they are zeros. Default precision is 6, means 6 digits are shown after the decimal. If the input number has more than 6 digits after the decimal point, it is rounded to 6 digits. If the input number has less than 6 digits after the decimal point, zeros are added at the end of the remaining digits. If you use it with integers, Python will convert it to a floating first and then to fixed point notation. You can use uppercase F. The difference lies in how special floating point values like NaN, not a number, and infinity are displayed. Use uppercase F if you prefer uppercase representations of NaN and INF. Scientific notation format type E formats a floating point number in scientific notation. This is useful for representing very large or very small numbers compactly. Default precision is 6. The number is rounded to 6 decimal places by default. Integers will be converted to a float first and then to scientific notation. You can use uppercase E. The difference lies in how special floating point values are displayed and how the exponent is represented. For example, use uppercase E if you prefer uppercase representations exponent E. General format type G formats floating point numbers using either fixed point F or scientific E notation, whichever is more compact. Uses fixed point notation F for most numbers, removes unnecessary trailing zeros. Switches to scientific notation for very small or very large numbers. Default precision is 6. Precision here refers to significant digits, not digits after the decimal point. Use uppercase G if you prefer uppercase representations of NaN and INF and exponent E. Percentage format type %. Formats a number as percentage. Multiplies by 100 and adds a % sign. Default precision is 6 digits after the decimal. Local format type N. Used for locale aware number formatting. If it automatically applies the thousand separator and decimal point according to the active locale. To use local format effectively, you must set the locale using locale.setLocate method. For example, here in USA, locale is set to US format. Dot is used for decimals and comma for thousand separator. Now change the locale to German format. Comma is used for decimals and dot for thousand separator. Precision. It starts with a dot and placed just before the type specifier. It has different effects based on the data type being formatted. Affects the floating point format types F, E and G and string format types S. For the floating point format types F and E, precision determines the number of digits after the decimal point. In these examples, precision is equal to 2, so 2 digits are displayed after the decimal point. For the format type G, precision determines the total number of significant digits, not just after dot. For the format type S, precision determines the maximum number of characters to output. Values formatted with the string format type S are truncated to the length specified by the precision component. In this example, precision is equal to 6, so only first 6 characters of the string are displayed. Width specifies the minimum number of characters the formatted output should occupy. It works with all format types, strings, integers, floats, etc. If the output is longer than the width is ignored, value prints in full. If the output is shorter than width, then it is padded with spaces. By default, strings are left aligned and spaces are added on the right. Numbers are right aligned and spaces are added on the left. For floating point types, the decimal point, exponent part, etc. are also counted. If precision and width are used together, then first precision is applied and then width. Sign component controls how signs plus or minus are displayed for numbers. You can use plus, minus or space. By default, positive numeric values do not have a leading plus sign displayed. Use the plus sign to show a sign for both positive and negative numbers. Use the minus sign to show a sign for only negative numbers, which is the default behavior. Use the space sign to insert a space for positive numbers and minus for negative numbers. Fill align controls how the value is aligned and padded within the specified width. It is the first value in the format specifier. Fill character is followed by an alignment operator. Fill and align work in pairs, of which fill is optional, meaning alignment can be specified without fill. Align controls how the value is aligned within the specified width. These are the options you can use for align: less than, greater than, caret and equal to. By default, strings are left aligned and numbers are right aligned. Use the less than sign to left align the values, greater than sign to right align the values, and the caret sign to center align the values. For sign aware alignment for numeric values, use the equal to sign. It forces the padding to be placed after the sign before the digits. Fill is a single character used to pad the output when the value does not take up the full specified width. It is used together with an alignment specifier and it determines what character fills the empty space around or beside the formatted value. If used without an alignment specifier, it will throw an error. In these examples, hello is aligned to the left and fill is specified as asterisk. Empty space after hello is filled with asterisk. Next, fill is used for padding a number with zeros. In the next example, fill is used with the sign-aware padding mainly used for financial numeric data. The equal to alignment with the zero fill keeps sign aligned with the digits. Hash activates the alternate form of formatting. Its meaning depends on the type of the value being formatted. Adds explicit base prefixes for binary, octal and hexadecimal numbers. When a floating point number with the fractional part 0 is formatted with the type G, default trailing zeros and decimal point are removed. Use hash to keep the decimal point and trailing zeros. 0 enables zero padding for numeric values. The 0 must appear before the width field. The number will be padded with zeros instead of spaces to fill the minimum width. For padding after the sign, use equal to, which is sign-aware zero padding. If you use an explicit fill and align, then 0 is ignored and padded with the fill character. For example, asterisk is used as the fill character here. Group controls how large numbers are grouped for readability, like adding commas or underscores. It comes after the width and before the precision if present. For decimal and fixed point decimal type, group can be specified as either a comma or an underscore. That character then separates each group of 3 digits in the output. For a floating point number, only numbers before the decimal sign are grouped. For binary, octal and hexadecimal, group can be specified as only an underscore character. Let's look at an example using all the format specifiers. Colon is the start of the format specifier. Asterisk is the fill character. The greater than sign specifies right align the value in the field. The plus sign forces the sign to be shown for both positive and negative numbers. 0 pads with zeros. Overridden by custom fill asterisk. 18 is the minimum width of the output including all symbols and digits. Comma is the thousand separator. Precision is 2 and type equal to F. Formats the value as a fixed point floating number with the 2 decimal places. First, the number is rounded to 2 decimal places. Commas are added as thousand separator. Plus sign is added. The entire string is right aligned and filled to 18 characters with asterisk. If fill is not specified, it is padded with zeros. To download practice Python file, please click on the link in the description. If you like this video, please subscribe to our channel.